Welcome to Science and Sleep, where knowledge becomes soothing melodies that guide you into dreams. Tonight, we will step beyond the familiar starry sky into the vast universe where giant galaxies drift and slowly collide in a dance lasting billions of years. Make sure to hit subscribe and stay with us until the end of the journey, for many fascinating secrets of the cosmos are waiting for you to discover. When we talk about galactic collisions, it's easy to imagine violent explosions or fragments flying chaotically through space, like scenes from a blockbuster movie. But in reality, the spectacle is nothing like that. What happens in the universe usually unfolds on enormous timescales, hundreds of millions to billions of years. So, from a human perspective, it resembles a slow dance rather than a catastrophe. Imagine looking at a pair of galaxies beginning to move closer together. From afar, they appear as two gigantic spirals of light, gradually pulled toward each other by an invisible yet powerful gravitational force. There is no sound, no smoke or fire, only a silent dance among the stars. What makes these collisions special is their scale. Each galaxy contains hundreds of billions of stars, vast clouds of gas, cosmic dust, and even supermassive black holes at their centers. Yet, when two galaxies collide, most of the stars don't actually touch each other. The distances between stars within a galaxy are so immense that the chance of two stars colliding directly is almost zero. Instead, what truly changes is the overall structure. Graceful spiral arms can be stretched, distorted into long, winding tails, or form bridges of stars connecting the two galaxies. Gas clouds collide, compress, and this very process triggers the birth of brilliant new stars. A cosmic collision, rather than being purely destructive, can actually give rise to new life. One fascinating example is the antennae galaxies, a pair of galaxies in the process of merging about 45 million light years from Earth. When astronomers point their telescopes at them, they witness a spectacular scene: streams of stars stretched into enormous antenna-like shapes, and at the center, gas clouds colliding violently, producing bright star factories. This reminds us that in the universe, the end of one form is often the beginning of something new and beautiful. However, what makes these collisions even more intriguing is that they are not just rare events happening somewhere far away. In fact, the Milky Way, our home, is also on a collision course with the Andromeda Galaxy. Observations from the Hubble Space Telescope and precise measurements show that Andromeda is moving toward us at about 110 kilometers per second. Of course, you don't need to worry. This collision won't happen for about 4 billion years. But essentially, our future has already been written in the curves of gravity. One day, the two galaxies will merge, forming a new supergalaxy that scientists have tentatively named Milkomeda. When imagining that future, it's hard not to feel both fear and awe. What will happen to the Sun and Earth during that collision? Supercomputer simulations show that the Earth might be swallowed or flung into deep space, but that outcome is not certain. Most models predict that the Sun could drift into a new orbit within a completely reshaped galaxy. And if life still exists on Earth or elsewhere humanity has migrated to, then we will witness a breathtaking night sky. Colossal spirals of light interweaving billions of stars blazing in a spectacle no artist could ever recreate. An interesting point here is that when galaxies collide, their central supermassive black holes also move closer to each other. Eventually, they will merge, creating one of the most violent events the universe can witness: a black hole merger. This event releases enormous energy in the form of gravitational waves, ripples that shake the very fabric of space and time. Humans first detected gravitational waves in 2015, and since then we have heard many distant black hole mergers. But imagine a collision between supermassive black holes with masses millions to billions of times that of the Sun. The signal from such an event would reverberate through the entire global network of gravitational wave observatories. And then, as the cosmic dust settles, the two once separate galaxies will be no more. In their place, a new galaxy emerges, often a giant elliptical one, where stellar orbits have mixed and the elegant spiral structures no longer remain. In endings, there is creation. In destruction, there is rebirth. Cosmic collisions, after all, are an essential part of the evolutionary journey of galaxies. Without them, the universe would be far poorer and less diverse. We might think of the universe as a stage where gravity is the choreographer and galaxies are the dancers. From time to time, solitary dances blend into duets, creating a performance that lasts billions of years. There is no soundtrack, no audience, yet the dance continues, silent, majestic, and eternal. And in the moment you look up at the night sky, seeing a faint luminous band stretching across it, the Milky Way, you are gazing at a dancer in the slow waltz of the cosmos. But the cosmic picture does not end there. When observing the complex paths of galaxies, we also encounter a subtler yet no less mysterious force: gravitational waves. If dark matter is the framework that holds every structure together, then gravitational waves are the invisible winds rippling through spacetime, carrying the messages of the most violent events in the universe. When two gigantic black holes, often found at the centers of galaxies, gradually move toward one another in a merger, they make the surrounding space tremble. Like a calm lake suddenly spreading ripples after a stone is dropped in, spacetime itself also moves, though at an incredibly tiny scale. And miraculously, humans, creatures that appeared on Earth only in the blink of an eye in cosmic time, have managed to build detectors sensitive enough to capture this signal. Gravitational waves are the music of the universe, music that needs no air to travel, but is written directly onto the score of spacetime. This brings us to a larger reflection. Perhaps the universe is not only to be seen with the eyes, but can also be listened to in other ways. Each galaxy is not merely a silent island of light, but a colossal instrument, occasionally resonating with deep tones when black holes or neutron stars collide. It is a kind of music beyond our direct perception, yet thanks to science, it has become tangible. And when we know that these waves originated from events billions of years ago in unimaginably distant regions, we feel as though we are reading a letter sent from the past of the universe. Yet, the most captivating aspect lies not only in the grandeur, but in how these invisible forces connect to our own existence. Without dark matter, galaxies could not maintain their shape to produce stars, planets, and ultimately life. Without gravitational waves, we would lack a sensory window to understand how the universe operates on its grandest scales. Both remind us that there are foundations of existence that cannot be sensed directly. They exist like silent artists, working in the dark, patiently waiting for billions of years to carve the masterpiece of the cosmos. And when scientists simulate the future collision of the Milky Way and Andromeda, they do more than draw a spectacular visual scenario. They also reveal a profound message. Nothing in this universe is eternal in its current form. Stars will eventually fade, galaxies will eventually merge, and even the universe itself is expanding toward an uncertain fate. But rather than being a source of fear, this change can be seen as a kind of rebirth. Like a forest sprouting green shoots after a fire season, each galactic collision creates a new environment where brighter young stars are born and where the elements essential for planets and life are spread more widely. From this perspective, cosmic collisions are not merely physical events. They are also lessons in patience, in the cycle between destruction and creation. The death of aging stars helps ignite the new generation. The dissolution of a spiral galaxy can become the foundation for a more magnificent elliptical one. The universe, through its very laws, reminds us that no ending is absolute. Every ending is simply a doorway opening to another chapter in the endless symphony. This also makes us reconsider, where is humanity's place within this vast dance? From afar, we are just a speck of dust in an ordinary galaxy. But from that very speck, we have reached out, observed, and begun to understand the grand forces that have shaped the universe itself. Perhaps true value does not lie in how small humans are, but in the fact that despite such smallness, we can recognize the universe's magnificence and retell its story through words, science, and art. If you look up at the night sky and see the light of a star, remember that light has traveled for hundreds, thousands, or even millions of years to reach your eyes. What you see is not the present, but a distant past. Each star in the sky is a message sent from the history of the cosmos. And when you see the Milky Way, like a luminous streak of spilled milk stretching across the sky, think that this very galaxy is also on its way to a great encounter with Andromeda. We are living in the silence before a symphony, but that silence has been enough to nurture life, love, dreams, and unending questions. Thus, speaking of galactic collisions is not only telling a scientific story, It is also a way for humans to reflect upon their own existence. We are born of stardust sustained by gravity and wrapped in the invisible framework of dark matter. We are moving along with our galaxy, and one day our descendants, if they still exist, will witness the sky transformed in ways never seen before. From this long perspective, each present moment becomes more precious than ever, for it is a single beat in the endless waltz of the cosmos. If we see the universe as a vast stage, then galactic collisions are its most magnificent scene changes. There is no noise, no smoke and fire as we often imagine in science fiction films, but rather a dance lasting billions of years, silent yet enduring. Gigantic star streams, once thought to be stable, begin to stretch and twist, forming tidal tails as soft as silk. In that immense expanse, each star continues along its own path, seemingly unaware that its entire galaxy, its home, is undergoing a great transformation. In this slowness, we perceive the universe's absolute patience, a kind of time not measured in minutes and seconds, but in eternal cycles. In the process of collision, perhaps the most miraculous aspect is not destruction, but creation. Vast gas clouds, once wandering through the emptiness between stars, are compressed, igniting new stellar nurseries. A generation of young stars is born, shining with energy greater than millions of suns combined. That light not only illuminates the new galaxy, but also helps scatter heavy elements carbon, oxygen, iron, the foundation of life to come. Thus, a collision is not an ending, but a doorway opening to a new chapter of creation. The universe in this way operates like an artist, always able to transform chaos into brilliant new works. Many people often picture a galactic collision like two enormous cities crashing into each other, buildings collapsing, roads breaking apart. But in reality, the distances between stars are so vast that the probability of them colliding is extremely small. What changes is not direct material impact, but invisible gravity, like conductors leading a grand orchestra. They stretch orbits, redirect motions, rearrange the entire structure. The final result is a galaxy with a new form, often a tranquil elliptical shape, less complex than the colorful spiral arms. Yet beneath that quiet exterior lies a turbulent history, a past layered with encounters. Sometimes mergers are not symmetrical. A small galaxy is absorbed into a larger one, like a stream flowing into a river. This phenomenon of galactic cannibalism is not cruelty, but an inevitable part of evolution. Today, astronomers can still observe faint streams of stars, the remnants of dwarf galaxies long since absorbed by our Milky Way. Those hazy streaks of light in the sky are living proof that galaxies are never alone. They always write their stories through interaction and union with neighbors. And this very absorption enriches the host galaxy with more stars, gas, and elements, fueling new cycles of creation. In particular, collisions can awaken the supermassive black holes at galactic centers. When gas clouds collide and collapse, part of the material is drawn into the black hole, releasing colossal energy, transforming the galaxy into a radiant quasar visible from billions of light years away. These cosmic lighthouses remind us of the unfathomable power of gravity, while also proving that even darkness can create dazzling light. The universe never ceases to transform when even a destructive force like a black hole can become the origin of beauty. Reflecting on this process, we cannot help but ask, what is humanity's place in such vastness? A galactic collision lasts billions of years, so long that all of human civilization, even all life on Earth, might rise and vanish before the event concludes. And yet, from this tiny planet, we are able to observe, predict, and even reconstruct the evolutionary history of galaxies. We are small, but not meaningless, for it is precisely our ability to perceive, to seek meaning in the immensity that makes our existence precious. And perhaps the most important message galactic collisions leave us is this: there is no absolute stability, but neither is there complete ending. Everything is in a continuous journey of transformation. A spiral galaxy today may become an elliptical one tomorrow. An aging star may explode to sow the seeds of new planets. Life on Earth, in some sense, is itself the indirect result of ancient collisions when elements were redistributed across space. Thus, each of us is a fragment in the universe's long symphony, born of stardust, living by starlight, and one day returning to the cosmos. When you look up at the sky and see light from distant galaxies, remember that you are gazing at an unfinished story. Those beams of light set out millions, even billions of years ago, only to reach your eyes today. Perhaps the very galaxy that emitted that light has already changed, merged, donned a completely different form. In this way, every star in the sky is not just a point of light, but a message from the past. And humanity, through imagination and science, becomes the reader of these letters, weaving them into the story of a universe in eternal motion. In the moment we gaze at the sky, it is hard to imagine that behind its calm appearance lie galactic performances unfolding over hundreds of millions of years. The encounter of two galaxies is not noisy like the clash of metal and stone, but rather a silent waltz choreographed by gravity, the invisible conductor of the universe. Thanks to gravity, stars do not plunge into chaos, but instead move along graceful curves, sketching magnificent forms. It is this fluidity that has led many astronomers to liken galactic collisions to a cosmic ballet, unhurried, unbroken, and stretching across endless acts. One of the most beautiful examples of this ballet is the antennae galaxies. From tens of millions of light years away, they appear as two long arms reaching into the void, bending softly like silk. Inside those giant antennae, clusters of young stars flare to life, marking the universe's birthday candles. Each of those stars will eventually age, explode, and scatter elements to build future generations. When we look at the antennae, we see not just a collision, but a rebirth in progress, a rhythm beyond the grasp of human lifespans. No less captivating is the Whirlpool galaxy, with its perfectly symmetrical arms spiraling outward like a blooming flower. This almost designed beauty arises from a simple truth. It is being influenced by a small companion galaxy. This partner stretches and curves the whirlpool's arms, making them more elegant than ever. Sometimes it is disruption itself that creates irresistible beauty, and so it is with human life. Often, upheavals and challenges shape our character and brilliance. These encounters leave marks not only in structure but also in the form of tidal tales, streams of stars and gas drawn into arcs, bending like strokes of calligraphy across the sky. They are the handwriting of gravity, inscribed upon the eternal page of space. Sometimes these stellar streams fall back in, contributing to unification, but at other times they remain as faint relics, preserving the memory of ancient meetings. They are like the universe's collective memory, wordless, yet glowing in the dark. We must also remember the galactic bridges, streams of matter connecting two stellar systems, like luminous spans between lonely islands. We often speak of human connection through handshakes or glances. Likewise, the cosmos has its own handshakes, stretching hundreds of thousands of light years. Sooner or later, these bridges collapse or are reabsorbed, but while they exist, they stand as proof of the communion of two colossal beings. They are symbols of fleeting yet meaningful bonds, much like brief encounters in human life that leave lasting impressions. Today, thanks to telescopes and computer simulations, we can not only look but also replay the choreography of these dances. From visible light, ultraviolet, infrared to radio waves, the universe reveals itself not as a lifeless void, but as a symphony of layered colors. Each wavelength is a note, and together they form the orchestra of the cosmos. When scientists compress billions of years into a few seconds of simulation, a miracle unfolds before our eyes. Spirals unfurl, tidal tails stretch, and then everything merges into a single form. Chaos turns into order, violence into dance, and time is woven into an endless patterned tapestry. What makes galactic collisions so enchanting is not only their imagery, but also the dualities they evoke: destruction and creation, ferocity and grace, transience and eternity. Within that duality, we recognize the essence of all existence. A galaxy may dissolve to give birth to another. A star may explode to sow the seeds of planets. Death is but the beginning of rebirth, and humanity, a tiny speck of dust, is capable of perceiving this truth while gazing at the sky. It is strange to think that in a few billion years, our Milky Way will also enter this dance with the Andromeda Galaxy. The night sky then will be transformed. A colossal spiral will appear, slowly merging into a new form. All of this happens far too slowly for any of us to witness, but the thought that our home is also on the path of change is a profound reminder. Nothing stands still. No structure, however vast, is more than a chapter in the universe's longer story. Perhaps that is why galactic collisions are not merely physical events, but pure artistic symbols. They are paintings the universe creates for itself, without audience, without intent, yet they move anyone who beholds them. It is a beauty beyond human aesthetics, one we can only describe with words like ballet, calligraphy, or symphony. And in using art to describe science, we admit that the universe is not just a vast machine, but a living poem written in light and time. In the symphony of the universe, galaxies are not merely dancers spinning in the void, but characters with their own personalities, narrating the story of their origins, transformations, and destinies. If the antennae are proof of violent upheaval and the whirlpool a depiction of a graceful yet dramatic relationship, then the Cartwheel Galaxy emerges as a most unusual creation, a pioneering work that only the boldest imagination could have painted. In the darkness of the sculptor constellation, the cartwheel turns like a colossal lantern wheel, its light radiating from billions of young stars blending into a dazzling circle. No longer the familiar spiral or elliptical form, it bears a unique structure, a radiant outer ring, spokes stretching toward the central core, all creating the illusion of a silent chariot rolling across the infinite horizon. It was this very difference that puzzled astronomers in its early discovery, for it fit no existing pattern. Yet, it was also this difference that transformed it into one of the most beautiful emblems of cosmic creativity. The origin of that extraordinary shape was a head-on collision. A smaller galaxy pierced straight through the cartwheel's disk like a pebble thrown onto a still pond. From the point of impact, ripples spread outward, compressing gas and dust, triggering waves of star formation like fire racing in circles. The cartwheel's bright outer rim is the leading edge of that ripple, where clusters of young stars erupt in pink and blue light. From afar, it resembles a fiery halo bursting forth, a testament to how order and beauty can arise from chaos. While the antennae recount the story of an ongoing merger, and the whirlpool displays the graceful performance of a cosmic duet, the cartwheel represents surprise, where even a fleeting touch can transform the entire appearance of a galaxy. It reminds us that in this vast material universe, even the briefest of interactions can leave eternal marks. And within the cartwheel's strangeness, we see a familiar lesson. Beauty does not always spring from perfection, but often from the unusual and the asymmetric. What binds these three galaxies, the antennae, the whirlpool, and the cartwheel, is not only their scientific symbolism, but also the aesthetic power they evoke. They appear on book covers, hang in science exhibitions, even become wallpapers on personal computers. They are like the movie stars of astronomy, resplendent with dramatic backstories. The antennae captivate with tidal tails stretching hundreds of thousands of light years. The whirlpool enchants with the delicate yet forceful embrace of its companion, while the cartwheel intrigues with its audacious form, a work of art that even classical theories could not have predicted. And if galactic interactions can give rise to such strange and beautiful forms, then at the heart of each collision we also witness another drama, silent but no less fierce, supermassive black holes. Hidden in darkness, invisible to ordinary telescopes, their power is absolute. Like gravitational anchors, they shape the orbits of stars, holding entire galaxies in their embrace. Yet, in encounters, those anchors become lead dancers, pulling each other closer, twisting in a fated dance. Imagine two galaxies approaching, each carrying within its heart a giant black hole, millions or even billions of times the mass of the Sun. As the galaxies pass, stars and gas are disrupted, pushing the black holes toward the center of merger. At first, they orbit each other from vast distances, silently and slowly. But orbit by orbit, they lose energy, drawn into an endless spiral. Finally, the two colossal shadows lock together, spinning at nearly the speed of light before merging into a single entity, releasing more energy than all the stars in the universe combined, but in the form of gravitational waves, not light. That moment no eye can see, yet the universe records its tremors. Ripples in space-time spread outward, quietly sweeping across Earth. To detect them, humanity has built delicate machines like LIGO and Virgo, capable of measuring shifts smaller than the width of a proton. And thanks to them, for the first time in 2015, we heard the universe's whisper, the signal of two black holes merging more than 1 billion light years away. From that day, we no longer only looked at the universe through light, but also listened to it through the rhythm of gravitational waves. If Hubble's images reveal the visual beauty of the antennae, the whirlpool, or the cartwheel, then LIGO lets us hear the melodies resonating from the darkest hearts of galaxies. And in the future, with projects like LISA, the space-based gravitational wave observatory, humanity will be able to hear the deep chords of merging supermassive black holes echoing for years. On a philosophical level, it is a wondrous step. We are not only observers, but also listeners in the grand cosmic opera. And in those dances, we realize that destruction and creation are inseparable. The collapse of two black holes into one is also the birth of a new gravitational center. The chaos of galactic collisions is the loom weaving the most radiant forms. We, sitting on a tiny planet at the edge of the Milky Way, can only glimpse fragments of these billion-year performances. Yet those brief glimpses are enough to move the heart, to stir the imagination, and to remind us that beauty is not only the product of human design, but also the natural language of the cosmos. Amid the vast universe, galactic collisions are giant canvases painted by nature with shades of chaos and rebirth. From afar, we see spiral arms stretched out, star streams torn apart, and woven into luminous bridges connecting two massive structures. But when we zoom in on the details, the story becomes much more delicate and gentle. Most stars continue their quiet journeys, almost unaffected by the cosmic storm unfolding around them. This may sound paradoxical. Why does an event as grand as the merging of two galaxies pass silently for most of the tiny lights within it? The answer lies in the immense scale of space, where the distances between stars are so vast that direct collisions are nearly impossible. Imagine a vast city where the buildings are separated by dozens of kilometers, and then two such cities slide past each other. From a wide perspective, the scene may seem chaotic, but for each individual building, everything remains still and steady. Galaxies are the same. As they spiral into one another, their immense gravity rearranges orbits, pulling some stars away, pushing others closer, creating dazzling tidal tails. Yet the stars themselves continue to shine, almost indifferent to the slow cosmic ballet around them. This reveals a wondrous paradox. The most spectacular things we see through telescopes are often those that least affect the existence of individual stars. And yet, that silence is not the whole story. When massive clouds of gas and dust, the raw material for life, meet, they ignite into showers of newborn stars. A galactic collision can transform a once quiet galaxy into a bustling star factory. Scientists call this a starburst, where the rate of star formation increases by tens or even hundreds of times. In the blue-white glow of young, radiant stars, we witness youth, vitality, and also brevity. For these massive stars often live only a few million years before exploding as supernovae, scattering heavy elements across space. This is the cycle of rebirth. Collisions bring death to some old structures, but at the same time spark the birth of a new generation. If we pause for a moment and imagine, we can picture galaxies as colossal dancers, hand in hand, spinning on the dark stage of the universe. Each turn not only reshapes their forms, but also engraves invisible ripples onto the stage, gravitational waves. These are minuscule vibrations in the fabric of space-time, spreading everywhere like the rising and falling tones of a cosmic symphony. Sensitive instruments on Earth have begun to detect these notes, allowing us to hear the dance that our eyes could never see. This is when science touches poetry. We not only observe with our eyes, but also listen to the heartbeat of the cosmos. Another marvel lies in the timescale of these dances. Humans usually think of events in terms of days, years, or at most a few centuries. But galactic collisions unfold over hundreds of millions, even billions of years. Through telescopes, we may see the image of a merger in progress, but for the event itself, it has only just begun. It will continue long beyond the lifespan of human civilization. This slowness reminds us of the nearly unbridgeable gap between our measure of time and the true rhythm of the cosmos. While we rush to count every hour, every day, stars quietly shine for billions of years, witnessing galaxies twist together, merge, and transform into a new entity. This offers a comforting perspective. In the vast universe, even the greatest upheavals may not disturb the existence of the smallest individuals. Our sun, for example, when the Milky Way finally collides with Andromeda, may still continue to shine, seemingly unaware of the grand performance unfolding all around. After all the violent upheavals of the universe, When the fierce collisions subside, we see an entirely different scene. The galaxies that once swirled in chaotic dances gradually stabilize, transforming into new structures with lasting balance. This is no longer the era of explosions and creation, but a tranquil epoch where maturity and stability become the defining features. The image of a golden elliptical galaxy quietly shining against the mysterious black sky resembles a resilient candle, no longer dazzling but steadfast, reminding us that peace too is a form of beauty. In this state, galaxies no longer give birth to countless generations of new stars. The gas, the raw material for the life of stars, has been largely depleted or blown away by the fierce winds of supernovae and energy-hungry black holes. Instead, the light they emit comes from billions of aging suns, lamps that have burned for millions, even billions of years. Their colors are no longer youthful blue, but gradually shift toward hues of yellow, orange, and red, like an endless cosmic sunset. If the era of starburst was a vibrant youth, then the epoch of elliptical galaxies is one of maturity, solemnity, and resilience. Remarkably, this very silence brings a strange sense of comfort to humans gazing at the sky. For in life, we too experience periods of turbulence, moments when everything seems shattered. But after all, peace will come, just as a galaxy finds new order after chaos. That image becomes a profound metaphor. Chaos does not last forever, and stability, though gentler in tone, contains enduring strength. The formation of elliptical galaxies also reveals secrets of cosmic physics. When two spiral galaxies collide, their fragile disk structures can hardly survive the overwhelming forces of gravity. The orbits of stars are disrupted. Instead of rotating in sync around the center as before, they begin moving chaotically, forming a rounder shape. It is this randomness that makes an elliptical galaxy look smooth and uniform, no longer bearing the graceful spiral arms. Yet this is not a loss, but the natural result of evolution, like a piece of music that, after swelling into its climax, slowly drifts into deep resonant notes. At the centers of many elliptical galaxies, supermassive black holes still reside, silently dominating the surrounding space. They are like quiet gods, not ostentatious yet exerting immense influence. Occasionally, a stray star or a stream of gas may be drawn in, creating a brief flash of light. Though rare, these moments reveal that even in silence, the universe still harbors energy awaiting release. The grandeur lies in the fact that silence does not mean stagnation. The stars within elliptical galaxies continue to move around the center, only now their motion is more balanced and enduring. In large galaxy clusters, elliptical galaxies often become the pillars, anchoring the entire structure. Some are so immense they contain trillions of stars, true empires of light in the universe. They are no longer youthful, but it is precisely their longevity that inspires a sense of magnificence and solemnity. From a human perspective, this state opens a reflection on life. Silence and stability are not signs of an ending, but a form of fulfillment. After the bursts of youth, after upheavals, we too find a slower, steadier rhythm of life, and it is that which carries lasting value. The universe, in its own way, has imparted a philosophy. Chaos and creation, destruction and rebirth, all ultimately lead toward balance. To behold an elliptical galaxy is to gaze into the living diary of the cosmos. Each star, each stream of light within it is a fragment of a violent past. Star explosions, compressed gas flows, collisions that once seemed destructive, yet all have merged into a lasting structure. It is not only science, but also art, the art of time and gravity, painted on the grandest scale imaginable. And then, when we look up at the night sky and see faint reddish-orange glows from afar, we know they are the lights of galaxies that have matured, wandering serenely in their cosmic twilight. They are proof that the universe, though ever in motion, still seeks to attain balance. That silence is not an ending, but a lingering melody, preparing for the new cycles of cosmic history. When we turn our gaze toward the faint streak of light in the sky, the Andromeda Galaxy, it is hard to imagine that this modest glow carries within it a grand destiny, to become the cosmic partner of the Milky Way. In about 4 billion years, this slow yet inevitable journey will culminate in a great union, completely transforming the night sky we once knew. That event, though so distant that humans today can hardly sense it intuitively, is one of the most vivid demonstrations of the universe's endless law of connection. No galaxy is forever alone. If you imagine the universe as an immense ocean, then galaxies are colossal ships drifting quietly, carried along by the currents of gravity. Andromeda, with a mass equal to or perhaps greater than the Milky Way, is moving toward our ship at about 110 kilometers per second. It may sound dizzying, but on the scale of 2.5 million light years, it is no more than the leisurely step of a giant. This slowness is precisely what makes the encounter a graceful dance spanning billions of years instead of a violent collision. In the early stages, as Andromeda draws near, Earth's night sky, if life still exists to observe it, will gradually change. The faint streak we are accustomed to seeing with the naked eye will expand, spreading wider and shining more brilliantly with each passing millennium. Then, one night, millions of years later, Andromeda will no longer be a faint blur, but a vast glowing disk covering the sky. That will be the moment when humanity, or whatever intelligence may remain, witnesses the slow yet irresistible union of two colossal stellar empires. What is strange is that although we call it a collision, most stars will not actually collide. The distances between them are so immense that even as the two galaxies interweave, the chance of two stars hitting each other is almost zero. Instead, the drama comes from the immense gravitational forces stretching the galaxies into brilliant light streams called tidal tails. These arcs span hundreds of thousands of light years, like ribbons of starlight unfurling in the cosmic wind, painting an enchanting dance no spectator could turn away from. This is also when star formation will be reignited. Giant clouds of gas, long dormant for billions of years, will be compressed by the gravitational tugs. The result will be countless newborn stars igniting, their youthful blue light brightening the dark corners of the galaxies. In that moment, the universe will seem to return to its youth, when energy and motion filled every void. If the elliptical galaxy stage is the deep, calm music of maturity, then the Milky Way Andromeda collision will be a brilliant symphonic climax, a crescendo before settling into a new stability. However, this union will not happen in a single instant. After the first encounter, the two galaxies will pass through each other, only to be pulled back together again. This process will repeat, like a long, drawn-out dance, each round reshaping the structure of both. The graceful spiral arms of the Milky Way and Andromeda will be stretched, distorted, and gradually lose their original form. After billions of years, the merger will reach its conclusion, a new, smooth, rounded galaxy. Most likely a giant elliptical will be born from the remnants of both. People have given it a playful name, Milkomeda, a blend of Milky Way and Andromeda. But behind this whimsy lies a grand vision, a larger, stronger galaxy containing trillions of stars, including the Sun and our tiny planet, if they still endure. The fate of the solar system in this encounter remains a fascinating mystery. Simulations suggest that while destruction is unlikely, our position will change significantly. The Sun may be flung far from its current orbit, or drift into a more distant branch of the new galaxy. It might even be swept into the glowing tidal tails, becoming a solitary lantern in the vast river of stars. Whatever the case, the night sky, as seen by any future descendants, will be completely different. Familiar constellations vanished, replaced by unfamiliar structures never before seen in human history. But what matters is not whether we will still be there to witness it. What matters is the meaning of the event. The universe is always in motion, always renewing, and no form is permanent. The Milky Way, the galaxy we call home, is only in a fleeting moment of cosmic history. One day it will merge into a grander, mightier whole. And this reminds us that even the largest structures are but temporary chapters in the endless book of time. In Andromeda's faint light tonight, we glimpse our own distant future. A reminder that change is the essence of the universe. What we deem stable will eventually transform, but from that transformation arises new beauty, a new order. The encounter between the Milky Way and Andromeda is not an ending, but a continuation, a new verse in the universe's eternal symphony. When we look back into the distant past of the universe, we see a picture completely different from the stillness of today's sky. Just a few 100 million years after the Big Bang, the young universe was still dense and chaotic. The first galaxies were not graceful spiral structures, nor balanced elliptical masses. They were merely small, distorted patches of light, overflowing with hydrogen and helium, forming stars at a breathtaking pace. The space between them was so narrow that collisions were almost inevitable. Each collision, instead of destruction, became an opportunity for creation, opening the stage for a new cycle of galaxy building. Imagine those primordial galaxies as seeds crowded together in a tiny garden. There was no room for them to grow apart, so their roots and branches had to intertwine. The result was violent collisions that compressed the gas, triggering explosive showers of star formation. Astronomers call this a starburst, the universe's giant fireworks of youth. Clouds of gas were squeezed tight, turning into millions of suns in just a few million years, a mere blink of an eye compared to the age of the cosmos. These massive stars lived fast and died violently, exploding into supernovae, unleashing energies that shook entire galaxies. It was these explosions that created the heavy elements: carbon, oxygen, iron, which would later become the rocks, seas, and life itself. Without those collisions, without those fierce starbursts, the universe might have remained filled only with hydrogen and helium, empty and monotonous. One could say that the violence of the early cosmos was in fact the cradle of diversity, sowing the seeds of life that Earth would one day inherit. Over billions of years, the universe continued to assemble larger galaxies from countless smaller fragments. This process is much like how humans build cities. Not in one go, but by gathering villages and towns, merging and expanding them. Today, every galaxy we see in the sky is the product of dozens, even hundreds of past mergers. Even our own Milky Way is a colossal patchwork, containing within it the remnants of countless companions it swallowed long ago. Astronomers discovered this by reading the chemical fingerprints of stars. Stars born in different galaxies carry different ratios of elements, like a genetic code. When scientists surveyed the faint halo of stars surrounding the Milky Way, they found groups with unusual characteristics, showing they did not originate here, but once belonged to another galaxy, later swept into the Milky Way through ancient collisions. We, in the end, are a collection of cosmic fragments bound together into a single whole. This leads us to another fascinating discovery: supermassive black holes. Most large galaxies, including the Milky Way, host a giant black hole hidden at their center, with a mass millions or even billions of times that of the Sun. But these black holes did not appear instantly. They began as smaller seeds, perhaps the remnants of the very first massive stars, and it was galaxy collisions that helped them grow. When two galaxies merged, gravity drove torrents of gas to the center. That inflow of gas fed the black hole, making it swell rapidly. Sometimes two supermassive black holes even met, spiraling around each other in a deadly dance until they merged, releasing energy in the form of gravitational waves, ripples in spacetime that modern observatories have only just begun to detect. Thus, from violent mergers, the universe not only birthed massive galaxies, but also forged the enormous black hearts, anchoring them. The wonder here is this: the universe both destroys and creates. Galaxies are torn apart, but from their remnants rise larger, more enduring structures. Stars die, but their ashes become the raw material for new generations, richer and more diverse. It is precisely this cycle of destruction and rebirth that allows the universe to evolve, transforming from an initial chaos into the rich tapestry we see today. And when we look up at the night sky, seeing distant galaxies shimmering, we are not merely gazing at islands of light adrift in darkness. We are looking into the history of countless collisions, of violent outbursts, of gravitational spirals that have woven the universe. Each galaxy, whether a graceful spiral or a silent ellipse, is a witness to billions of years of turmoil. And within that turmoil, a new order is always born. In the vast universe, nothing remains still forever. The galaxies we see quietly hanging in the night sky actually carry within them the memories of colossal collisions. Every faint stream of stars, every streak of light curling like a ribbon in the dark, is the remnant of galaxies once torn apart and merged. When we look more closely, from our Milky Way to the nearby Andromeda, those scars emerge clearly as imprints of an ancient history. Overlapping star rings, delicate shells of gas, ripples undulating like a lake just struck by a stone. Astronomers often call these structures cosmic fossils. They are not stone fossils like on Earth, but fossils of light, preserving the memory of collisions that took place billions of years ago. From the initial fragments, the universe gradually built magnificent structures, spiral galaxies, giant elliptical galaxies, and dense star clusters stretching across the sky. In every faint outline of theirs, we can read the story of the universe's evolution, a story that never ends. What astonishes us is the scale of time. For humans, hundreds of millions of years is an unimaginable span. But on the universe's timescale, it is only a brief breath. Collisions can last for hundreds of millions of years, unfolding so slowly that if we lived a whole human lifetime, we would see little change in a galaxy. Yet, placed within the frame of billions of years, the dance becomes clear. Galaxies once distant slowly approach, twist into one another, and merge into a new entity. The Milky Way and Andromeda are living proof. At present, they are still about 2.5 million light years apart, a distance that seems eternal. But gravity has sealed their fate. In about 4 billion years, they will collide. This process will not be a single explosion, but a dance lasting billions of years. The two star disks will entwine, streams of gas will be pulled into glowing tidal bridges, and millions of new stars will be born. One day, the merged galaxy will become a giant elliptical supergalaxy, likely holding within it the two massive black hearts fused into one. But galactic collisions are not only violent convulsions of space. Hidden within them is the individual story of each star. A galaxy can host hundreds of billions of stars, each silently passing through its own life cycle. A star's fate is bound to the struggle between gravity and nuclear fusion. For most of their lives, stars remain in the main sequence, stable and radiant like our sun. But fuel does not last forever. When hydrogen runs out, the core contracts, the outer layers expand, and the star transforms into a red giant. The sight is both majestic and terrifying. A once modest star suddenly swells, potentially engulfing the planets that once orbited it. If we take the sun as an example, one day it will expand enough to engulf Mercury, Venus, and perhaps even Earth. Yet this expansion is not only a farewell. When the outer layers peel off, they form a planetary nebula, glowing clouds of gas like ghostly flowers blooming in space. Behind that beauty remains the stellar core, compacted into a white dwarf, hot, dense, and fading silently over billions of years. Much more massive stars meet a far fiercer fate. They live briefly, burning fuel like a torch blazing at full force. At the end, they explode as supernova, blasts that can outshine an entire galaxy for a fleeting moment. From these explosions, the oxygen we breathe, the iron in our blood, the carbon in our cells are forged and scattered through space. In other words, we are all children of supernova, stars that died to give the universe the chance for life. After a supernova, the leftover core may become a neutron star, a sphere only a few dozen kilometers wide but heavier than the sun. Matter inside is so dense that a teaspoon could weigh billions of tons. Some neutron stars spin at astonishing speeds, emitting beams of radiation sweeping through space, becoming cosmic lighthouses, pulsars. And if the mass is even greater, nothing can halt the collapse. A black hole forms, swallowing everything, even light. In galactic collisions, the fate of individual stars does not change. They burn according to their predetermined rhythm. But their surroundings are violently transformed. Giant gas clouds are compressed, triggering starbursts. New generations of stars are born, repeating the cycle, shining, expanding, exploding, then returning their matter to the cosmos. It is precisely this interplay between galactic collisions and stellar life cycles that weaves the ever-renewing tapestry, where nothing is lost, only transformed. When we gaze at the night sky and see thousands of twinkling stars, many of them may have been born from such collisions. Some will end quietly, becoming lonely white dwarfs. Others will die in violent bursts, sowing seeds for the next generation. And in all of this, one truth remains undeniable. We, from our bodies to our breath, are products of countless cosmic collisions that have unfolded since the dawn of time. The universe is not a motionless mass, but a vast recycling engine, running through collisions, deaths, and rebirths. Every galaxy we behold, every star we see, is proof of that eternal cycle. And perhaps it is within chaos that we find order, and within destruction that we discover the seeds of creation. When we talk about galactic collisions, we often imagine it as a play of stars, billions of suns rushing past each other in a symphony of light. But the truth is far more subtle. In that cosmic backdrop, there are also the silent giants playing a decisive role. The supermassive black holes residing at the centers of every galaxy. Normally, they are so quiet that one could easily mistake them for redundant dark spots in the universe. Yet, when a galaxy quivers from collision, it is they who awaken, opening some of the most dramatic chapters in cosmic history. Imagine, in the moment when two spiral galaxies are merging, all the gas and dust that once circled serenely is suddenly shoved and tangled like a cosmic storm. Gravity compresses this material toward the center, like underground rivers suddenly rushing into the same ocean. There, the supermassive black holes that once dined sparingly are suddenly offered a grand feast. They begin devouring thick streams of gas, forming enormous accretion disks swirling and glowing brighter than an entire galaxy combined. It is at this very moment that we witness the birth of active galactic nuclei, AGN, brilliant milestones on the cosmic map. These AGN can shine so intensely that they outshine hundreds of billions of surrounding stars. Within this dazzling glow, energy erupts not only as light, but also as intergalactic winds blowing gas away, reshaping the destiny of the galaxy itself. The universe, through black holes, seems to both destroy and reorder. Even more astonishing, many AGN launched jets, towers of energy and matter stretching thousands of light years, piercing space like colossal arrows of light. These jets, shaped by the twisted magnetic fields within the accretion disk, can reach so far that they heat and stir the intergalactic medium, affecting star formation in neighboring galaxies. In other words, black holes do not only consume, they also breathe out, and that breath has the power to reshape the structure of an entire corner of the universe. These discoveries not only bring wonder, but also raise profound philosophical questions. How can an invisible entity, one that allows no light to escape, become the brightest source in the cosmos? How can destruction be tied to creation? The universe seems to be telling us a paradox. Within the deepest darkness lies a radiant force, and somehow this mirrors the journey of life itself. From chaos emerges order, from darkness is born light. Going further, when two galaxies merge, it is not only the supermassive black holes that awaken. Eventually, at some point, the two central black holes also begin their own deadly waltz. At first, they orbit each other at a great distance, but over time, each revolution shortens the gap. Gravitational friction and the loss of energy in the form of gravitational waves draw them ever closer until they merge into an even larger black hole. That moment, if captured as an image, would be like the universe plucking a deep note on the harp of space-time. Gravitational waves, ripples spreading across the fabric of space-time, are released, traveling for billions of light years and sometimes reaching Earth, where sophisticated detectors like LIGO or Virgo can listen to them. It is extraordinary to realize. From a collision in some far-off place, billions of light years away, faint vibrations can still reach this planet, allowing humanity for the first time to directly hear the whispers of the universe. This makes galactic collisions a grand stage where many layers of phenomena intertwine, from the bending of light by dark matter to the blazing beacons of AGN to the resonant echoes of gravitational waves. All of it blends into a cosmic symphony that we are only beginning to understand. Every telescope perched on mountaintops, every satellite orbiting Earth, every gravitational wave station beneath the ground is like an instrument helping decode this universal melody. And as we gaze at the bigger picture, a simple but powerful truth emerges. The universe is not still. It is an unending process of transformation. Supermassive black holes do not only swallow light, they orchestrate and shape the fate of galaxies. Dark matter is not only an invisible backdrop, it is the skeleton on which the drama is built. And within every chaos, a new order waits to emerge. Perhaps the greatest message the universe sends us through these collisions is this: no ending is ever truly an end. Even in the most violent collapse, there lies the seed of a beginning. Galaxies merge, black holes grow, dazzling light bursts forth, and the echoes of gravitational waves ripple across space. The universe continues to write its story, and we, as we listen, are in a way reading each page of its diary through the very light and sound of the stars. On the journey of the universe, there are moments when darkness and light meet, creating spectacles beyond all bounds of imagination. One of these is the appearance of quasars, blazing cosmic lighthouses born when supermassive black holes are nourished by streams of matter flowing inward during galactic collisions. Normally, spiral galaxies maintain an orderly dance, keeping gas and dust quietly suspended within their vast disks. But when two galaxies meet, that balance collapses. Gas is compressed, collides, and is drawn toward the center like rivers swept away by a storm. There, the sleeping black hole suddenly awakens, hosting a feast whose light can tear through the cosmic night from billions of light years away. In those moments, galaxies are reborn. A once quiet galaxy can suddenly turn into a dazzling quasar, radiating more energy than hundreds of billions of stars combined. Astronomers call this the active galactic nucleus phase, a period when the black hole not only devours matter but also transforms destruction into extraordinary light. Sometimes, in the early stages of a merger, both central black holes simultaneously feed on gas, creating dual AGN systems, a pair of blazing cores shining like two signal lamps in the endless sky. Yet this symphony does not last forever. Over time, these black holes begin to drift closer, spiraling inward under dynamical friction and energy exchanges with surrounding stars. Each orbit shortens their distance until, at last, they merge into a larger black hole. In that instant, the universe trembles. Gravitational waves, ripples in the very fabric of spacetime, are released, carrying information about the merger and spreading outward across the cosmos. Humanity, with sensitive detectors stationed on Earth, can sometimes listen to those faint echoes, as if hearing whispers from a distant past. But before that tragic finale, the black holes pass through a radiant phase. As they consume matter, not only light is released, cosmic winds, jets, and fierce radiation are blown outward, carrying energy capable of shaping an entire galaxy. This phenomenon, called feedback, can strip away the gas needed for star formation, turning a youthful galaxy into an old, barren one. Or it can compress gas into dense clouds, igniting the birth of new generations of stars. In this cycle, the black hole is not merely a destroyer, but also an artist, sculpting the destiny of the galaxy that hosts it. What is fascinating is that the link between galactic mass and the size of its central black hole is no coincidence. Collisions are the bridge that drives black holes and galaxies to grow together. As galaxies grow larger, so too do their black holes. And through each merger, each luminous feast, that relationship is reinforced. Looking back to the early universe, where gas was abundant and collisions frequent, it is easy to see why quasars blazed far more densely. In today's universe, where galaxies are older and gas poor, these lighthouses have become rare, like living relics of a golden age. Yet even now, collisions can reshape the cosmic landscape. The Antennae galaxies, 45 million light-years away, are vivid proof. Though their central black holes do not shine brightly enough to become quasars, the inflow of gas has triggered furious starbursts, illuminating their spiral arms with new life. And when we look to the distant future, about 4 billion years from now, our Milky Way will merge with Andromeda. Their central black holes will enter a deadly dance before becoming one, perhaps igniting a quasar-like blaze before settling into the form of a new galaxy. What amazes us lies not only in these physical phenomena, but also in the broader context. None of these events happen in isolation. Galaxies are not lonely. They are links in the cosmic web, a vast structure like a spider's net, woven from filaments of dark matter in galaxies stretching hundreds of millions of light years. Within this web, collisions are not random, but inevitable outcomes of gathering matter. Like droplets flowing along river networks, matter streams down cosmic filaments, pooling into dense nodes where galaxy clusters form. And there, mergers occur frequently, shaping the face of the universe. Even we ourselves are indirect products of that chain of collisions. The Milky Way once swallowed smaller galaxies, leaving traces in its stellar halo and in the chemical composition of stars around us. Some of the heavy elements in the human body were forged in ancient stars of galaxies long gone, dispersed and mixed during mergers. In other words, the story of the universe does not only write the fate of galaxies, but also writes our very existence. And perhaps that is the greatest wonder. Collisions that seem violent are in fact the heartbeat of creation. They remind us that destruction and genesis are two sides of the same essence. When we look at brilliant quasars in the night sky, we see not only light from billions of years ago, but also a subtle message. Even in the deepest darkness, when the conditions are right, the universe can burst into its brightest flames. If we look at the universe with the patient eyes of time, we will realize that spectacular collisions are only part of the story. Alongside grand mergers like the Milky Way and Andromeda preparing for their monumental union, there is a quieter yet equally important process: the cannibalism between galaxies. This is not a destructive violence, but a form of patient evolution, slow, subtle, and more creative than annihilating. In the cosmic ocean, the small galaxies, often called dwarf galaxies, are the fragile companions. They have few stars, little gas, and most of their mass lies in the dark matter halo surrounding them. Orbiting larger galaxies like satellites, they resemble faint flickering lights, always vulnerable to the immense gravitational pull from the center. And so once they come too close, a dwarf galaxy begins to stretch, its layers of stars and gas torn apart like a thin silk veil carried away by the wind. This is the cosmic feast, not devouring in a swift bite, but unfolding over billions of years. Our Milky Way is a vivid example. If we observe the halo surrounding the galaxy, we will see faint streams of stars, curved like silver rivers flowing through the darkness. These are not spiral arms, nor natural structures from the Milky Way's birth, but remnants of small galaxies that were absorbed. One of the most famous among them is the Sagittarius dwarf galaxy. Once, it orbited the Milky Way like a loyal companion. But over time, the gravity of the larger galaxy gradually broke down its integrity. Now, its stars stretch into a winding stream, wrapping around the Milky Way like a torn silver scarf. From within, the stars of these dwarf galaxies rarely collide directly with each other. The distances between stellar systems are too vast for physical collisions to occur. Instead, their experience of being devoured is more like a slow migration. The stars simply change their orbits, drawn into a new gravitational field, and gradually merge into the stellar ocean of the larger galaxy. If a civilization existed within a planetary system belonging to Sagittarius, they would not perceive violence, but rather see their night sky slowly changing over billions of years. Familiar constellations stretching, new rivers of stars appearing, until one day they would realize that their galaxy itself had vanished, dissolved into a grander system. The universe is full of such examples. The two Magellanic Clouds, small satellites of the Milky Way, are also being influenced by its immense gravity. A stream of gas hundreds of thousands of light years long, called the Magellanic Stream, has already been pulled away, flowing into the Milky Way like a cosmic river. This is a precious source of fuel for new star formation, showing that cannibalism not only destroys, but also nourishes. These absorptions provide new material, enrich chemical compositions, and fuel the life cycles of young stars. On a larger scale, giant elliptical galaxies, the smooth behemoths often seen at the centers of galaxy clusters, have almost certainly formed from countless cosmic meals. Astronomers, when observing their vast halos, have discovered myriad faint streams of stars, the scars left behind by previous absorptions. If we imagine the Milky Way and Andromeda as two dancers preparing for a grand merger, then elliptical galaxies are the heavyweights who have endured hundreds of battles, consuming one opponent after another to become massive and enduring. Andromeda, our close neighbor, is no exception. Studies of its halo reveal traces of many dwarf galaxies that were once torn apart. As it approaches and merges with the Milky Way in a few billion years, the two will share this same voracious history, continuing to transform by absorbing their remaining satellites. This process, though it may sound destructive, is in fact an engine of evolution. Without it, the universe would be less diverse, less abundant, and galaxies could never reach the grandeur we see today. Interestingly, galactic cannibalism is not ostentatious. It is patient, silent, almost meditative. Gravity is never in a hurry. It only pulls, only bends, only slowly rearranges everything. The result is that even in loss, there is beauty. Stellar tidal streams glisten like galactic ribbons, curving across space, serving as monuments to a history both quiet and poetic. Perhaps that is why this phenomenon brings us such profound reflection. Destruction is not always cruel. In the hands of the universe, destruction is an art of transformation. The stars that are swallowed do not disappear. They merely change stages, from playing roles in a small galaxy to harmonizing in the symphony of a greater one. The universe wastes nothing. Everything is preserved, reused, and elevated. If we view the universe as a banquet, dwarf galaxies are the appetizers, while grand mergers are the main course. But in every case, what we witness is not waste, but an endless cycle of creation. Each absorbed dwarf galaxy is a new chapter in the evolutionary book of the larger one. And one day, when the Milky Way merges with Andromeda, the entire history of dozens, even hundreds of small galaxies that were once devoured will also be integrated, continuing the cosmic epic. In this light, galactic cannibalism is no longer a dark tale. It is a reminder that existence is always tied to connection and transformation. Even in loss, there is creation. Even in dissolution, there is rebirth. The universe, through its very workings, teaches us that everything, even disappearance, is only another way of continuing the journey of beauty and life. When we look at galactic collisions, we often think of destruction, of a cosmic earthquake where everything is torn apart. But reality is far more subtle. Behind the stretched spiral arms, the tidal streams of stars flowing like ribbons in the dark, lies a song of resilience and renewal. Stars rarely ever truly collide. The distances between them are so vast that each collision is more like two cities of light passing through one another, like their inhabitants continuing their journeys without ever knowing. Thus, instead of an ending, collisions become the driving force for new beginnings. When two galaxies entwine, their massive clouds of gas crash and compress. From this, stellar nurseries erupt into new generations of suns, points of light that would never have existed without that impact. It is creation ignited in the very heart of the storm. Without such cosmic encounters, the universe would perhaps be far poorer, with fewer stars, fewer planets, and maybe even fewer chances for life. In fact, it is collisions that have shaped the very face of the universe we gaze upon tonight. Fragile spiral galaxies can mature into round, stable ellipticals. Scattered galaxy groups can merge into colossal clusters, where trillions of suns orbit in a silent dance. Each merger is a vast natural experiment, where starlight and time patiently write out the results. Astronomers, by observing, read precious clues. Why one galaxy erupts with stellar fire while another fades away. Why dark matter, the invisible cocoon surrounding them, dictates the shape and destiny of entire worlds of light. What is astonishing is that these collisions are not just science, but also art. Images from the Hubble or James Webb telescopes show us galaxies embracing, spiral arms curling into radiant arcs, their cores blazing like fiery hearts. These images are no different from gigantic oil paintings, where gravity is the brushstroke and starlight the colors. Each collision is a unique masterpiece, yet all share the same themes: transformation, endurance, and beauty born from chaos. Looking deeper, we find a lesson in resilience. A galaxy may be stretched, twisted, even folded into an entirely new form, but it does not vanish. The stars continue their slow journey around the gravitational core, like travelers who never cease walking. Gas and dust are flung away, only to gather again, creating fields of young stars. And from what seems like ruins, a new shape emerges, stronger, steadier. In this way, collisions remind us that even in the most violent upheavals, the essence of existence endures. This also opens a philosophical view. The universe is much like human life. We go through upheavals, through collisions that seem to destroy everything. Yet over time, those very collisions shape who we are, give us strength, give us a new form we could never have imagined before. Like galaxies, we are not merely survivors, we are beings reborn. On the night sky, when you see two galaxies drawing each other into a slender bridge of stars, you are truly witnessing both the past and the future at once. The past, because that light began its journey millions of years ago before reaching your eyes. And the future, because that very sight will write the form of an entirely new galaxy billions of years from now. In that moment, the universe reveals its wonder. Even chaos is part of order, and even destruction is a form of creation. Seen from the perspective of eternity, collisions are not catastrophes, but instruments of evolution. We see turmoil, but the universe sees architecture. Every merger is a brick in the colossal building of time, every tidal stream of stars a stroke on the infinite canvas. And each time we look up, we are reminded. Beauty exists not only in stillness, but also in the most violent collisions. In the infinite silence of the universe, galactic collisions reveal a lesson in patience and resilience that few metaphors on Earth can compare to. When two galaxies gradually draw into each other, We often imagine instantaneous destruction, but in reality, it is a slow and graceful process. So much so that if humanity could observe it directly with the naked eye, we would only see a still image, like autumn gently turning into winter. Gravity is never in haste. It stretches across hundreds of millions of years, arranging every curve of stars, every wave of light, as though weaving a vast tapestry. It is within this silent rhythm that we learn great change never arrives like a sudden storm, but rather like a patient river carving into rock, leaving behind cliffs and canyons of enduring beauty. The galaxies, with their grace, remind us that upheaval does not mean an end, but an opportunity for renewal and the opening of new possibilities. When our Milky Way is destined to merge with Andromeda, it is not a forecast of an ending, but a prelude to a new cosmic form, where stars are rearranged, where new planetary systems kindle the spark of life. The beauty of this process lies in connection. No galaxy stands alone, just as no human being is truly isolated. Gravity weaves galaxies into clusters, filaments, and superclusters, and with it, collisions become infinite bridges, proving that all existence in the universe is bound within a vast network. From our perspective, those radiant spirals may seem like nothing more than dazzling optical phenomena, but from the universe's perspective, they are rebirth, its way of preserving life and beauty through each cycle. And in understanding this, we also come to realize that even in the most chaotic moments of life, there is always a deeper order silently shaping the path ahead.